Okay. So there is a criteria which is used to see if that particular job resume or the job description matches your description or not, and that happens up here. Parse scored jobs. So jobs are scored by AI. It gives it particular scores on based criteria, and that is defined by the prompt that I give it. Okay, and here is the prompt that I have given it. If we look at it, score each job 1 to 10, return only 7 plus, and like this is a very simple prompt, but you can customize this to have particular criteria based on that. Most commonly I've observed that AI is pretty good at doing that, so you don't have to give it a very detailed job description, but most of the time it does a good job. So that's the whole thing. Find job listing, create custom resumes and custom cover letter for me, tell me that there's a particular job which matches my criteria, let me apply and do it for different types of jobs. Okay, it's as simple as it gets. But then how do we do it? Okay, let's first see the whole workflow in running. Okay, I had to pin this results because this particular AI node takes a bit of time. Since we are self-hosting, Google takes time to verify all the data. I'm going to unpin all the data. I, Again, as I said yesterday, you can navigate through nodes using this button right here. Unpin, next node, unpin, next node, unpin. Okay, now the nodes split somewhere. Yes, they do. Ah, unpin the data. Perfect. So all the data has been unpinned. Now we are going to take a look at how the workflow first runs and maybe walk through it simultaneously, or we can do that later as well. Okay, so the initial thing that I was, now we all know that you need a trigger to trigger a workflow. So the my choice of trigger was job application. I could have used a manual trigger, I could have used a web application, I could have used any other form, which the only thing is it should provide data, and I found that this is the simplest form of getting data. So here it is. Okay, now let's do execute step. When I click execute step, a form appears, right? This is the form, and all the fields in the form, as we all know, are defined up here, right? You can customize every single thing in this form. You can even connect it to a Google form using a webhook trigger. But why do the extra work when it's already integrated up here? All right, let me upload a sample resume. Okay, now let's say I want to find jobs for CTO positions. Okay, submit. Form submitted. Okay, now as you can see, as soon as I submitted the form, this is the file that was uploaded, right? I cannot pin this type because the data type is binary. Again, one more thing in the UI, both the inputs and outputs have their different forms. And as we discussed, n8n is very JSON heavy. So every single output and input is obviously going to be in JSON. So if I try to look at JSON of this particular input, this is how it's going to be. The data remains the same. The only thing is, for your visual parity, you can look at it as a table or you can look at it as a schema. Schema is particularly useful, as we'll see in the upcoming nodes, but for visual clarity you can view it as a table or you can view it as a JSON. But this particular data cannot be pinned because it is of type binary. If I try to pin this, it gives me a warning: pin data is disabled as this node has output contains binary data. So binary data, which means you have uploaded a file, cannot be pinned. That is the only limitation. Okay, now we have the file uploaded. As you can see, this particular node ran successfully. Now let's move to this node. What does this do? Now I have uploaded my resume. Now I want to extract the text from this resume, right? Okay, so let's run this node. Yeah, okay. As you can execute the node from here, simultaneously you can also execute the node from this button, execute step. Okay, we are going to use this because we want to look at the inputs and outputs. Now let me execute the step. executing node, and this is everything that it has extracted. Now let's just look at the file once. Okay, downloads. This is my sample resume. I have not updated it. This is just a random, not random. This used to be my actual resume, but okay. So these are all the fields available, but this is in PDF form, and we expected it to extract all of that. Let's just see if it did a good job of it or not. Let's just look at them side by side, right? Let's just see what it brought out of it. Okay. First are going to be the file information. Info contains file, PDF version, blah blah blah. This is of none of our concern, so uh, we just collapse it. If you are observing, we are viewing it in schema mode because it allows me to go around data and also drag and drop all of that data in future. If I'm configuring a node, I can drag and drop these schema to input them into the particular node. We'll see. Okay, then metadata. Again, metadata is of no use to me. This is what I want, text, right? This is the text it has extracted, and as I can see, most of it is correct, right? Contact, my email address, my LinkedIn profile, my top skills, and etc, and the whole thing. If I want to look at it in detail, I'll go to table, and then I'll go to text. This is the whole text that it has extracted, right? You can go ahead and see if it has done a good job. If it has not, you can configure another node. You can use a paid service, you can use AI, whatever. This is a PDF build, and it has an input inbuilt node called extract from file. We looked at it yesterday. If this one does your job, oh, perfectly fine, continue with it. If not, you can use external service as well. Okay, again, you can also look at it as a JSON. Now what I will do is, I don't want to come here and upload this image again and again when I am using this workflow or testing this workflow. That's why I will pin this data. This data is pinnable because this is simple JSON, right? This is not binary, this is extracted text. That's why we can pin it. Now we have pinned the data. Now let's just close this. Okay. Okay, now let's go to the next node. Now what does next node do? Prepare resume data. Okay, that was extracted data. Now we wanted to have particularly extracted data. Why? Because that particular thing is going to be sent to a AI resume parser, right? And this needs formatted data. If we just dump all of this data into it, it's going to create garbage in, garbage out. That is the LLM's base philosophy. So we don't want to send everything. We want to send things which makes sense to this. What has to be done with this extracted data? If I just give the extracted data to this AI parse node, it will simply summarize it for me that, okay, I have received a bunch of strings, this is what it means. I don't want that. I wanted to prepare resume data out of it. So what I've done is I've created two fields. First is resume text key. What was the text extracted? And if you look at this, what is this? This is not the resume text that we were promised. This is json.text. What does this mean, and where did it come from? So as you all know, if we look at it correctly, input from this node goes to output from this node is treated as input for this node. So anything on this side of this node will be mirrored on this side of this node, right? So if I look at it, the right side output is going to be exactly identical to the left side of this node, correct? Now why do we have this schema tab particularly? So that when I'm configuring this node, what part of this output of previous node has to be brought in into this node and then processed can be dragged and dropped into this field using these schema nodes, or like this schema tab. If I go to table, I cannot drag and drop it. It just simply selects it. If I go to JSON, I cannot drag it because it simply selects it. If I go to schema, it makes individual buttons out of every single thing that was extracted: title, author, subject, and I can drag and drop them. This is called referencing. If you guys are familiar with programming, we have reference variables, right? What are they called? If anybody is from a bit of programming background up here, what are reference variables in programming called? Anyone? It's pretty simple. It's not that difficult, to be very honest. Pointers, correct. Very good. Pointers. So these act as pointers to the data so that this whole place where I have to input that data doesn't get cluttered. Okay. And how do they point to that particular thing? Ampersand JSON, dollar sign JSON dot text. Now what does this JSON mean? JSON is simply the output of this previous node, and this JSON will mean different on different nodes because they'll be referring their own outputs. So this particular node, in this particular node, if I write JSON, this means this whole JSON. And what do I want out of that whole JSON? Do I want info? No. Do I want metadata? No. Do I want text? Yes. And that's why we have JSON.text. Let's have two examples. Okay. And if I click on this, you can see what does it resolve to. If I click on this, it resolves to this. And this is exactly what we wanted, right? Contact, name, and everything that was extracted from the workflow. And the type of that data is string. This will come in play when you get into branching the data, because let's say you set up a type of data which is not acceptable to a node down the stream. This will cause issues. So be mindful of what you set the data type as. Okay. Now I can do this. I can write this manually, json.info. Okay, I can write this info, and this will be a valid thing. Why? Because the info field exists here. Where did it go? Extracted. This info field exists here, right? Info field exists here. That's why this is valid. If I type something which does not exist, it's going to give me an error. If I say info, error, right? Red background means error, green backgrounds means the thing exists. Now let's say I don't want to type this. Okay, I don't want to type this. I want to drag and drop. So that's why these buttons are here. First, you make sure you're in the schema tab. Click on the click on the type of data that you want to drag it into any of the fields. You can place it anywhere. Let's say I place it here. It brings all of that metadata into this particular thing. Okay, as of now we don't want to give metadata, so we'll. And what do these curly braces means? Does anybody have an idea what these curly braces means? Any idea? It is very intuitive, to be very honest. And I asked in the previous scope, more than scope. This is not scope. Curly braces present scope in terms of functions or loops. Here it means JSON. Yeah, it's basically syntax of JSON. So okay, where did my Excalibur. Okay, yesterday I kept out a poll asking, are you guys familiar with API and JSON? So API stood for Application Programming Interface. JSON stands for JavaScript Object Notation. Yeah, JavaScript Object Notation. Okay. So what JavaScript Object Notation is a very self-explanatory term. JavaScript is a language used in web. Object is a construct of that language, and notation is the way to write it. So every JSON will have its curly braces. Anything in between these is going to be a JSON. Okay, and then there are steps to a JSON. So basically, how many stepped JSON is this? This is a single step JSON. If I create a JSON like this, let's say, and there has to be there has to be indentation between them, or else it's wrongly formatted. This is the syntax of a JSON. Okay, then there are different things, like there is going to be a key and there is going to be a pair. There's going to be key pair values, and the fields in JSON, they are called fields. The key pair values, you can assign them, you can have empty or whatever you want to do, and you can nest any number of curly braces inside it. There's no limitation to that. Okay, and if you can write them like this, you can also write them like this, right? Let's say this is a single step, this is double step, right? This expands to this, right? Simply just for our sake, they have written it like this. Okay, and in there we have JSON dot whatever value you want, say like info, right? And this references, and because you want a reference, that's why we add a dollar sign. Okay, that is how this particular thing, where did it go? This particular thing came into the picture. Okay, so anything that you want from the output, simply drag it, make sure you're in the schema tab, grab it and place it here. It will resolve to it. Okay, and what did it resolve to? If you want to see, you just simply click here and it shows you a rendered preview. Okay, let's say this place is a bit cluttery for you, you want to have a bigger view, you just press this button up here. Okay, you click this and now this whole result is shown to you in detail. Okay, but we don't want to see it. It can also render HTML. If I suppose, yes, you can render HTMLs, you can render markdowns, you can render text however you want. Okay, So this is what the expression was, and this is what the resolution is. Okay. Okay, so now we have this, we'll execute this step. This, what does this do? It basically formats the data into these two things. It first accepts the resume text, whatever came in, and then it gives a job hint. What is the job hint? This is the job application form, item.json. What jobs are you looking for? That was received from the job application form. This was the field. What jobs are you looking for? We entered CTO, right? And that is there. So we want this, whatever the user entered, we want to drag and drop that into a job hint field, which will be provided to whom? Which will be provided to the AI. Okay, now let's execute this node. After execution, it's like nothing complicated. It just formats data out of all this garbage that we got, like the info, the number of pages, the PDF format, language, linear. We don't need any of that. We don't need metadata. So we customized what we need. We dragged it into the fields, and then we formatted it. That is what this format field or format data node is used for. Okay. Okay, so now it executed perfectly. Now this is AI parser node. I'll simply click it. We'll not go into details because this whole node takes, let me just simply tell you what it does. Again, same thing. Like I don't need to explain it 100 times that this is the input, this is the output. Again, we got all the JSON response from the previous node. This is the prompt. Because this is an AI node, it obviously has to call the AI, and to call AI, it is going to require a prompt. And the prompt is dead simple. What is the prompt? Take the resume text. This is the user job preference, whatever was my preference, and we have referenced it. We have not hard coded it. I cannot type CTO here, because then regardless of whatever is typed before this or whatever the user has submitted, it will always search for CTO. We don't want that. We want whatever the user asks for it. Okay. Then we give it a task, analyze this resume, extract the structured profile, return only valid JSON. This is really important because we are in n8n and we need valid JSONs. If it returns a non-valid JSON, this particular workflow fails. And that is the reason I say LLMs are not predictable. If let's say a LLM hallucinates, something happens, network stream goes off, server sent events, dropped a particular event, anything happens, one notation goes out of place and the whole JSON is non-readable. That is how strict JSON is. You cannot add commas randomly in between here. You cannot add spaces. You cannot have you cannot not have indentation. You cannot have random curly braces, unfinished curly braces. Any of that and a JSON is completely corrupted. Okay. At least to the system. To us, we know, okay, it's a simple thing, but to the system, it's corrupted. Okay. Did it complete? There is an issue. What is the issue? Okay, we changed it in between, so it won't execute. We'll have to run it again. Okay, it's really simple. We gave it a simple prompt. Let's look at the detailed prompt. Analyze this resume, extract a structured profile, return only valid JSON objects with keys, name, email, phone number, location, experience level, blah, 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 blah. And again, not once, but twice have we wanted that only return valid JSON, no markdown, because there is a tendency based on the type of data the LLM is trained on, it will either return JSON, markdown, HTML, it has its own preferences. We don't want that. Okay, we force it. And most of now newer models, the new generation of models, they come with a particular key, or like let's say when you call their APIs, they have a parameter which tells you JSON only mode. Gemini was the first one to pioneer it. It's called JSON only mode, which we don't have to explicitly mention it on the prompt. The system prompt of the model itself tells it to only and only only return valid JSONs and nothing else. And that was the need of industry, because automations and every other platform which uses API mostly uses JSON, and that's why it's very important. Okay. Okay, amazing. It has executed perfectly. Let's look at the response. Did it complete what we wanted it to do? Yes, it has. It has given us a valid JSON. How do we check if it's valid JSON? Turn to JSON tab and verify. Is this a valid JSON? Yes, because had it not been a valid JSON, this would have thrown an error or had shown us something. All of this into a red background. Okay, it has exported a correct JSON. Okay, amazing. Now we have our JSON passed by AI. If it were not for this AI parse resume, we would have had to go through this particular node, adding 15 to 20 fields and then dragging and dropping them each one of them. That is also a way to do it. That is sure shot. Again, everything comes back to this particular thing again. Had we used a inbuilt node, everything would have been predictable. Why? Because we ourselves have dropped everything into the fields. We know if the user and extraction has worked perfectly, it will reach this extract node perfectly, because we made sure we ran through every single possible flow and decision right here. But since AI is doing it right here, it's making my job easy. I don't have to drop 15 fields. And let's say this resume changes tomorrow and there are experience level is missing. What happens then? Then I have to take care of that particular situation here. If, then we'll have to introduce a if node. If experience level missing, add a zero in its place or whatever, and then I'll have to do it for 12 different fields. I don't want to go through all of that mess. So 12 nodes were replaced by a single node. That is the power it gives you, but again, it is unpredictable. It can make mistakes. Okay. Next node, a simple search query node. What this particular thing does is it creates a search query valid. Wait, let me explain the next thing for you. But before explaining this, I'll explain this so that this will make sense. Okay, what are these? These are APIs. Himalayas and Remotive are two free APIs which lets you search for jobs. You can look them up. Here it can be any single API. It could be LinkedIn, it could be Naukri.com, it could be Google search with tags, it could be what do you call Glassdoor, it could be any other provider with their paid API key. I just found that these happen to be free and easily available. That's why I use them. So why did we create this? What do you call? Why did we have this build search query node? Because these are API calls. If we look at it, these are HTTP requests, and to where do these HTTP requests fire? They fire to this particular API, right? HTML himalayas.app/jobs/API search, right? And then that search, if most of you are familiar with APIs, again, it comes back to being familiar with APIs. When you call API, the parameters are passed inside the URL, right? We have to build the URL by defining the parameters, the headers, and the what do you call, the security headers, right? Everything has to be put in, and then you have a valid URL which you can hit. To create a valid URL, we had to push in all those parameters up here, right? And to get that, we have this particular node. That is all this node is doing. All this complicated code that you see, it's just creating a valid URL query for Himalayas and the other API to use. Okay. And then injecting all of our resume data into that. Now let's run this. Okay. This is the valid JSON that it has created. And then we go to the Himalayas. Now let me fire this. Again, the same thing happens. You take everything from here, drag and drop it here. You get this, you drag and drop that. Again, I go to Himalayas. What I want out of this is the API, and this is the encoded URI component JSON target, blah, blah, blah. This is what was created by the previous node. Okay. This is what was created by the previous node, and we are referencing it up here. Okay. If you look at it, it's different this time. It's encoded URI component. This was the output from previous node. Where did it go? It's to be somewhere here. Okay, encoded URI component. Nahi, एक second. Encoded component has to be here somewhere. Uh, 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 uh. Did this come from JSON.targeted keywords? Acha, okay. This might be a function. Okay, URI function. Fine. We are not referencing encoded URI component. We are referencing targeted keywords, which was generated by the build query node. Okay. Next, where do we go from here? We run this node. Now we are running two nodes in parallel. That's why we need a wait for both API nodes. Had this node not been here, if there were this node was not there, either we use only one single API, so build query goes to Himalayas and then straight goes to merge and normalize. If we want to use multiple nodes, then we have to wait for both the APIs to finish. Otherwise, what will happen? A single one will run, give the output to this, and this one will create an output that will never be taken into account, right? We don't want that. We want both the nodes to finish running, and then we wait for the, okay, so both the nodes have finished. What's your problem? You need to define at least one pair of fields to match. Execute. Okay, okay, okay. Wait. Okay. I don't know why it was changed to. Wait, there has to be a problem with the JSON. This should not have been combined. It has to be append because this node is simply supposed to take these two responses and add them up here. This node is supposed to do no formatting whatsoever. If you use this combine thing, then basically you have to map these fields. So what that means is response from Himalayas and response from Remotive is assumed to be same. So both of them will have same fields, but that is not the case because Himalayas has different APIs, Remotive has different APIs, and we cannot map those fields. If you look at it, fields to match, we cannot map them because they have two completely different fields. If you look at the Himalayas response, it is going to have different fields. If you look at Remotive's response, it is going to have different fields. So we cannot map them. Thus, this particular node cannot have a combine mode. It will always supposed to have append mode. Okay, and number of output is 2 because we have two APIs. Then we run it. Perfect, this runs, and then we run merge and normalize. This is just a simple uh, JavaScript code which takes all the fields and normalizes them so that it can be sent to AI again. If you observe, every time we send something to AI, we have to prepare the data, right? Every time something has to be sent to the AI, we have to prepare the data. This whole node does the same thing. Okay, it takes all the JavaScript bullshit out of it. Like, look at this location restrictions, time. No, no, not this one, but it's to be somewhere down. API has been updated. We don't need that updated offset limit total count. We don't need all of that, right? We only need the responses and in formatted way such that AI can use it. Now let's run the AI node again, just like last one. This has a prompt, candidate, the user profile, job descriptions, task, score each job, the number of jobs returned. Now, how do we know how many jobs were returned by the APIs? There is a visual indicator. What is the visual indicator? Here. If you look at it, if I hover over it, it gives me option to either add a new flow or delete this flow. What happens if I click delete? This particular flow will be broken between these two and then I can connect it somewhere else. But as far as we know, there are two items. So basically it means the Himalayas only returned one job matching CTO and Remotive also returned only one job matching CTO. Both of them were merged and that's why we have two items. They were sent into merge and normalized jobs. They have been sent to AI. Now AI will take its sweet time to format all of them and then score all of them because there are two of it. So it will have to make two trips. Then we wait for it. By the time this finishes, does anybody have any questions? Please put them in the chat. Can you use multiple merge nodes? But why do you want to use multiple merge nodes? Let's say you are you talking about this merge node, the blue one? Doesn't matter. You simply go into this merge node, extend the number of inputs that you want. Let's say you want 9, 10, however many you want. Just put the number there and you will have those many inputs up here. You don't have to use multiple nodes just for this, right? Also, I forgot to pin data since we were here. Let me pin data here so that we don't have to run everything again in case this AI fails or something happens to it. Again, AI is unpredictable. If you observe last time it ran very quickly, now it's taking its sweet time and there is some error. Service unavailable, try again later, blah blah blah. Okay. Gemini service is not available. We'll try to run it again. Pin this as well. Also, in the web version of this n8n, to the right of it, you will find a AI chatbot which can look at your workflow, help you debug your workflow, also create workflows for you. So, but the hosted version doesn't have that as of now. I don't know. This chat feature is completely different from that chat feature. This chat feature is here to test your models, the models that you have enrolled, the API keys that you have enrolled. It's for that. But there's going to be a chat bot or chat section right down here on the hosted platform or on the cloud platform. You can use it to debug your workflows, ask about your workflows, what's happening, where is happening, and n sort of things. Also, you can just connect Cloud Code to n8n now, so that is also a way. If this doesn't, okay, perfect, amazing. Ran, spin it very quickly. Okay, so this is the response from our AI that it has it done? It has followed our prompt. It has ranked all the jobs from 1 to 10, okay, based on the criterias and everything. Now we need to use this data to parse the scored jobs. We don't want everything, right? We want to parse only the job that match our criteria. Okay, then we parse it. And out of all of them, wait, how the hell did we get 5 items out of it? Acha, okay. For different criteria, we got it. Now, this is a comparison node. If you look at it, if node. So if what does if node do? That if a particular criteria matches our given input, then we go ahead with the loop. If it does not, if it does not, oh wait, something is wrong. Huh. Okay. If it does not, it does simply what it does. It simply gives us a mail response that no matches were found for the criteria and the job description that you have sent. No matches were found. But in case the matches are found, which we'll see if they are or not. Okay, 5 items have been matched. Now we go to the loop. Wait, if we go to loop, or is it going to send me mails? Go here, send, cloud console, APIs. Client, okay, there are values. All right, should send us a email. Let's loop through one of them. Looping goes, we send everything to AI, the description, the job resume, the found job description, and our resume. Why are we giving it to AI right now? So that it can create a tailored resume and cover letter for us. Okay. Now it is taking all the information that it has about us, that it got from our resume, that it got from our descriptions and from everything, and it has created a so how do we create a PDF? So again, if you recognize this particular node, I am using HTTP request node, and to whom? To api.html pdf.app. Now what is this HTML to PDF? What is this? This is an online service which converts your HTML to PDFs. Now, as we know, LLMs are not inherently capable of generating PDF data. They can either generate text or they can generate HTML. And more out of that, HTML is much more PDF friendly because it has sections. So we can have headers, footers, you can have the alignment, you can have spacing, you can have everything defined in HTML, and that is easily convertible to PDF. If it were a simple text output, that would have been very difficult to convert into PDF. Now we have a text. Let's convert it into PDF. First, let's get a resume out of it first. Right. Arey yaar, I forgot to pin the data. Pin the data. Okay. Okay, amazing. It just went ahead and created a PDF, created a resume. If you look at it, this is the file. I can simply look at down. I can download the file and look at it. What has it generated? See? I don't need to do this, but I can. This is what it has generated. Okay, this is my tailored resume for that particular uh, job. Okay. Now, what is the next step that it will do? It will upload it to Drive, right? That was the next thing it should do. And now this is where action nodes come into play. Yesterday we discussed about action nodes. We created our Google credentials. This is what I have set it up here. Okay. Google Drive account. Okay, OAuth 2 API. Yesterday we created that. File is source, up operation is upload. There are n number of operations that you can perform. You can create from text, delete, download, move, share. So it can do these number of things on my drive. Then this is the file name and everything. But the major thing is, where do you want it to upload? So the parent drive is going to be my drive, and it has to have a folder called n8n upload resume. It will not automatically generate n8n upload resume folder. I will have to manually first create that folder, and I have created that folder. Okay, n8n upload resume, and there has to be another folder called n8n cover letter. Okay, cover letter has already been uploaded. Now let's upload the resume. Okay, let me click upload resume. Oh, come on. Print this. This is the issue with triggering individual nodes from here. It cannot resolve the dependency chain, and it goes back to the last common point and then continues the flow from there. So that is it, why it is really important that you pin everything. You cannot pin these responses because, as we know, this is a file has binary, and binary cannot be pinned. So now everything has been done. Let's see. Drive upload resume. Let's check, was it uploaded? Is it uploaded or not? My drive. Cover letter. Can I look at the cover letter? Amazing. This is the cover letter. Dear Planet hiring team, as a co-founder of CTO, you can space blah 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 blah. These are my this, and this is a. I simply copy it and send it as a mail. Okay, that was the cover letter, and this was uploaded thrice because I ran the workflow thrice. Then I look at the resume. This is the resume that it has created. It also named it Parikshit Joshi hyphen planet hyphen resume, and this is the resume that it has generated for me. Now I have kept it dead simple so that it we can test it out at a pace. If you were to stylize this, add images, add footer, header, and all of that stuff, it can take about 2 to 3 minutes to be generated. Okay, but the main point is that it gets generated, uploaded, and then the next part of our workflow says that they were logged into sheets. Was it? Can I check it? Let me go to the sheets, and again the same thing that happened with drive. I created my credentials, I attached my drive. Again, one thing that you have to keep in mind, that all the Google Drive API or the Google APIs that you want to use will have to be activated up here. Now this is not the account that I used, this was the account that I used, and this is the project, n8n self host. These are all the APIs that I have enabled. Had Google Sheet API not been enabled here, I couldn't have accessed the Sheets API. Had not Google Drive API been activated, I couldn't have accessed my Google Drive. Had not Gmail API has been activated, I couldn't have accessed Gmail Drive. And it shows every log that my n8n API, these are not the logs, these are my Claude logs, but Sheets and Drive, these are from the n8n workflow. Okay, you can have a detailed look at what happened, when it happened, and why did it happen. You have metrics, you have quotas, credentials, drive, you have blah blah blah. You have like all the things available to you right here. Okay, it will take time, it will load drive lists. So this is what, these are all the requests, these are all the methods that were used, the latency, the errors, and blah 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 blah. Okay, but make sure you come here, you go into this particular button, enable APIs and services. We went through this yesterday, right? You go here, you search for, if you want to, let's say, use Drive, you say Drive, you have this Google Drive APIs, and you enable them. So it will not tell me to enable them because I've already enabled them, and it will just ask me if I want to manage them. Okay. Let's move ahead with the, okay, now let's check the sheet. Was it uploaded to the sheet or not? And again, similarly, I have created this sheet myself. Okay, this was not pre-created. If you go into that node, you'll see that I had to configure it to add to this sheet. Google Sheet account, again the same thing. I could use any of these. Sheet with document, append up. What do I want to do? I want to append a row. I don't want to clear anything. I want to create or nothing. I just want to append a row. Then from document n8n. n8n is the name of the sheet that I have created, right? This is the name of the sheet that I have created, and in that I have sheet 1. Now what is sheet 1? As you all know, Google Drive supports multiple sheets in a single documented sheet. So right, if I click here, the next sheet will be added. For out of that, I want sheet 1. That's why we have a sheet 1 tab up here. Okay, sheet 1. Then map automatic. You can either do it map each column manually. What that will do is you get the complete control. So all these headers, kind, ID, name, mime type, blah 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 blah. I chose for auto add. That's why I have all this garbage in here. Let's say I did not want any of this kind, ID, name, or maybe I wanted name, but I did not want kind, ID, mime type, started, trash, blah blah blah. I don't want any of that. This version, web content link, I don't want any of that. So in that case, what I could have done is I could have went here, I could have map automatically jagah, I could have selected map each column, and then out of this result I could have manually chosen again the same thing, drag and drop only the things that I need. Just to save time for all of us, I just use map automatically. Okay, and then we have map automatically done, and a mail sent to me. Again, we configured it yesterday. Again, same thing, Gmail account. What do you want to send? This is the way I want it to look, the split resume cover and everything. This is the email ID that I want to receive the emails on, and this is the subject that should have it, the job match found, and do this, add this. Then the score was 8 out of 10. That's why it was passed. Anything about 7 is passed. And then this is the detailed message. I used Claude to generate this HTML just so that I can have a bit good UI in my email. I don't want to see just random text strings. Okay, that's why we have a HTML in here, and this will be rendered in the browser. If you want to look at it, this is how it is going to look. Okay, it can be completely controlled from right here. So your AI tailored blah blah blah, I change it, it goes there. Okay, now let's see if the mail was sent to me or not. Actually, which ID did I send the mail to? I sent the mail to this ID, right? And then let's go and check, did we receive the mail? Okay, perfect. So job match intern found at email. If I say apply now, it will go and apply. Okay, and you will be taken to that particular link, himalayas.ai intern and ml, and I can apply it from here. You can go one step ahead and make it auto apply on your behalf, but that will require a lot of browser magic. Let's not go there, but we prove the point that we have successfully completed the workflow. Where is the workflow? Okay, then what it does, it goes back to the loop. How many items were there? 5 items, so it will go around 5 times. So we should have practically received 5 times. One, two, three, four. We received four. So maybe we did something in the fifth one. Maybe we clicked the change. Yes, correct. We clicked the change in the fifth one. And that's why it says the node parameters have changed. There's a no again. But if we do it again, it is simply going to send me the same email with the fifth item. Okay. That is how we complete the whole flow. Had this not matched, it would have went to false and it would have told me no match is found. But it hardly happens because every single position that you apply for at least has one match, right? That is all for this particular use case. Now I open the chat. There is a Q&A section in your drop down. You can use it to put Q&A questions, and let's get them answering. Okay, Sandeep, I remember you asking a question yesterday. We couldn't get to it. You feel free to do it right now. One really useful use case that I could think of today was PhonePe sends you uh, emails for every single transaction, regardless of 5 rupee, 10 rupee, 1000 rupees, doesn't matter. It sends you an email with receipt for everything, right? What you could do is attach an email node, get all the emails from PhonePe, log them into a Google Sheet, and that way you can manage your money and also like get the stocks from a live stock website and see where you can uh, invest those. But obviously, don't take financial advice from me. Mohit, there?
Yeah, yeah, I'm here.
Okay. So there technically is the end of the content for this two sessions. Now I can open the session for Q&A. Like go ahead and ask. Okay, huh. So Sandeep is asking, I was asking regarding differences between LangGraph, LangChain and Copilot Studio. Okay. Are you referring to the Copilot Studio by Microsoft? Because there are multiple, there is Copilot Kit. Okay, perfect. So the difference is, I'll first start with LangChain and LangGraph. Okay. LangChain is the pioneer of AI agentic SDKs. That was the first SDK which was released by a open source team to create AI agents. Back when AI agent as a concept did not exist, there were only LLMs. But soon people realized that talking to LLMs is fine, but you need more from LLMs. You need memory because so that the LLMs can talk to you with historical context. You need storage for them so that you can give them files which they should refer to before talking to you. That could be your personal document, that could be your company's documentation, that could be your private API documentation, anything, right? Fourth, you needed them to take actions on your behalf. So maybe call APIs, just like n8n does. It calls actions on your behalf, action nodes. So they wanted LLMs to be able to take actions, call functions, right? To do that, you needed to pipe the input from one instance to another. Let's say you invoke the LLM somehow using transformers library or any other Python code, you invoke the LLM. Now the result has to be piped into something. Initially, this was done by simple function calls. So result of this function goes into a bucket and then is used as a parameter for the next function. That is how we do it in programming, right? We needed and there were no AI specific terminologies. So let's say you go to use a language today, you use Python, you use JavaScript, everybody has their base constructs, right? Base data types, base functions, the what do you call, the schema of how a function should be written, the syntax basically. And what that allows you to do is manipulate data and create function, create processes. There are only two things in programming, functional programming. There are processes and there are data, and processes manipulate data, and that's how new state is formed. So there was nothing present for LLMs to be able to do this. You had to rely on languages like Python or JavaScript to do this, but they did not have AI native terminologies. Although the data remains the same, it is obviously going to be a JSON, it is obviously going to be a function call, but the terminologies did not present, and everybody was inventing their own new terminology. Somebody called it result, somebody called it response, somebody called it text, and that created chaos. So the first group or the first company to come up with a nomenclature for this type of chaining of data was LangChain. And why did they name it LangChain? Because LLMs are large language model. The response is in language, the input is in language. So lang from language, and chaining means chaining the outputs together. So your prompt is changed to chained to the response, is chained to the memory, is chained to the tool it takes, and is chained to the response. So the language or the tool which helps you chain these language inputs was called LangChain. It gave you primitives to be able to orchestrate data around LLMs. That is what LangChain did. But eventually we realized, or the people realized that never or very rarely is the flow serial, right? This will happen, then this will happen, then this will happen, then this will happen. This is very rare in terms of LLMs because LLM can generate random data at random times. And back then LLM are not as good as they were today. They generated absolute shit, and that is why you came up with LangGraph. Now LangGraph is a fork of LangChain and builds on it. It builds on something called DAC, basically acrylic graph. So actually now if I get into DAGs, it is going to be a really big session. We will cover it in L1, but let it be known that graphs lets you perform actions, or rather perform workflows as we did in n8n, right? You can branch workflows, you can take decisions at runtime, you can let LLM take decisions at runtime, you can pipe inputs from one graph to other. And that's why they called it lang graph. Lang graph is not that different from langchain, but the only difference is it helps you think in terms of graphs. That is how LLMs think. That's why we have two different workflows, LangGraph and LangChain. And Copilot Studio is nothing but just a like rip off of tools like n8n and Visual Interpreters, which lets you build AI agents visually. So it's nothing that special. Microsoft has never been known to make anything original. They took the OS from a different company just to sell it to someone. So like I really don't like Microsoft products. Just a disclaimer. So LangChain, LangGraph, yes, worth learning. Copilot Studio, maybe, may not. In fact, LangChain has their Lang Studio or their a visual builder which lets you build AI agents visually. You can drag and drop stuff, add prompts, just like n8n, as good as n8n. Okay, I hope that answers your question. Got it. Okay, perfect. Anybody else? Any doubts? Anything you want to talk about? Share. This basically paves the way for me to tell you that in the L1 course, this is exactly what I'm going to take. The primitives of AI, how to think about. Okay, so let me just give you a very brief overview of what the AI space looks like right now. Actually, we'll stop calling it AI. Let's call it uh, the LLM space. It's a better word for it. Now, if I were to give you a brief introduction on it, this is the complexity graph. Okay, this will show you complexity. Okay, this is very, very high, or let's say, uh, let's start with low. Okay, complexity, this is low and this is high, which is very obvious. Okay, now if you start from, let's start from high. It goes into neural networks. Okay, neural networks and basically the math behind everything, the math behind it. You'll have to learn machine learn, basically let's call it machine learning. Okay, this is the pinnacle of it. Then a bit closer to that is going to be models, model infra. When I say model infra, it does not mean the infrastructure that the model runs on, but rather what the model comprises of. Basically, here you talk about transformers and their architecture. But the own transformer architecture only. If you go here on this level, there are multiple architectures, right? Uh, for different machine learning models, there are different architectures. But we like when you talk about AI or LLM in general, like let's just not call it AI because this whole thing is AI. But LLMs, rather very specifically LLMs, right? We can talk about the models infrastructure, internal infrastructure, the transformers, their architecture, different architectures. It could be BERT or it could be a diffusion. Like there is a new model with diffusion architecture made. So it's called Mercury. Okay. So this is very new, but just for the sake, I'm keeping it here. This is the level where you talk about all of these things. Then if you come a level down, this is where you talk about applications. This is where you talk about LangGraph, LangChain, or what do you call Google's one ADK, Agent Development Kit, you call Vercel's AI SDK, or there is Crew AI, then there is Magentic One or something like that. Something all these SDKs. Basically, this is applicative layer. Okay,
Strands as
you
well.
talk about applications. Okay,
Strands.
strands, or like there are n number of them.
Yeah.
Okay, applications. This is the applicative layer. Then you go one level beyond. This is where you talk about the UI, literal UIs of it. So basically, now again, the Copilot Studio, right? Copilot Studio. Again, n8n comes into it because they are heavily focusing on AI. but I would place n8n not here, but rather somewhere between. It's here, somewhere here, because no other UI will give you as much control and as much flexibility as n8n. That's why I'm placing it somewhere here. But other like Copilot Studio and all the UIs that help you build these agents are here. And then the lowest is ChatGPT. ChatGPT, Claude, not Claude Code, Claude. Okay, the UI. Then Gemini. All of these are the UIs that you use in browser based UIs. Okay, these are the browser based UI. This is the lowest level. When you go on a browser and talk to ChatGPT or Gemini or Claude or any other model, that is the lowest tier of at. Okay, I am assuming like this is developer perspective. Okay, we are not users. This is developer perspective. From developers perspective, this is the lowest. Now, if you are talking in terms of users, this is where it starts. Okay, this is where it starts, and kindly this is where it ends, because users are never expected to build something. We are talking about developers perspective. So browsers are the lowest complexity, then comes UI which helps you build agents, then come application SDKs like LangGraph, LangChain, ADK, blah blah blah. Then comes learning how LLMs work, basically fundamentals of LLMs, models, their infrastructure, transformers and BERT and everything. And then the pinnacle of it is the math behind it. Okay, the absolute deepest level, like here you enter into research category. Okay, this is research category, and this is the lowest of research category. And then from here it starts for research category. Then the very next step is vectorization, or rather let's say not RAG. I would place RAG is an application, so RAG can be kept somewhere here. Okay, RAG is an applicative thing. It can be kept somewhere here. Research, here comes fine tuning. Okay, and this is done using Clora, QLORA, and LoRa, LOR. Clora and quantized low rank adaptation and low rank adaptation. Then above it, you go one step ahead, and this is like full fine tuning. Okay, this is like no. You don't spare any of the neural nodes to anything. You just wipe everything, like not wipe everything, you affect everything. Then comes steering an LLM. This is new. This is very new. Steering an LLM, what does this mean is when you are asking an LLM, like you change the node parameters of that LLM at runtime on inference time. This is not done on it, not at inference, but before. This is done before inference. Like you'll have to spend days and hours and a lot of GPU compute doing this, and then you run the model. And once you fine tune it, you can only use that model. You want to change something, you fine tune it again. Steering is a very what do you call, next level approach for LMs. This happens at runtime. This is a bit complicated. I should not get into it right now, but at runtime, then beyond that, like experimenting with new architecture. Even I haven't been here experimenting with new architectures. This is where this model, like this one, diffusion from Mercury. So this is where we GPT is a generative pre-trained transformer. BERT is bidirectional encoder and a represented transformation. But this one, the diffusion Mercury, this was not common till now. This has been done very recently. So diffusion is a technique which is used by vision models, or rather image generation models, but they implemented it into large language models. So this is the territory where this happens, and then like this is unknown. Like I don't know yet. This is still growing. So if you want to get into research, do all of this. If you really want to get into like applicative layer of LLMs, start here, maybe jump up to applications, model infra transformers. I don't know if you really want to get into it. This is good to know. This is starting to get into research territory. Maybe good to know, maybe not good to know. So the sweet spot to dwell is right here. Okay, some of this, maybe not at all this, somewhere here. If you really want to be a competitive developer. Yes, Mohit.
I mean, basically application layer where all the money is right now. I mean,
Exactly. Yes,
if
that
you,
is the
yeah, if
nobody
you
cares about how much you can fine
say,
tune a model, or like a few companies do, but then you have to be a specialist and you need to have
yeah,
a machine learning background from
bang
5 years.
bang, and yeah,
But
exactly. Yeah.
mm,
And also like
also, yes,
maths, main important is maths. Is real need for the.
correct. Okay, just I'm sorry, I got distracted by the question, but this is the answer to the yesterday's question that I asked, where what is the fourth thing required by a LLM to be a truly agentic agent? First was memory, second was tools, third was what was third? LLM, like you need an LLM, then you need a memory, then you need a tool calling, function calling. The fourth was Ralph loop. If an LLM cannot think on the result it has generated itself and then respond and then again think about them and again respond, if it cannot perform this loop, it is not agentic. It is a simple chatbot. You give question, it gives answer. You get question, it gives answer. It is not agentic. For it to be agentic, it needs to think upon the result it has generated, and that is called a Ralph loop. Okay, we'll also cover Ralph loop in like this applicative layer. So wait, what was the question? Can we convert the n8n workflow into a Python code? See, you can convert it directly into TypeScript code because n8n allows you to have TypeScript SDK. It is official TypeScript SDK, and because it is n8n, n in the first eight, n before eight is standing for node, right? Node is what? It's a runtime manager for and run like the one thing that runs whole thing runs on TypeScript, right? It helps you run TypeScript, JavaScript, everything. It's browser based, mostly on the client side of things, and maybe a few server side of things. But if you want to convert it into Python, there is no direct way to do it. You create it into TypeScript or like export it into a JSON, convert it into TypeScript, give it to Claude, give it to Gemini, give it to any other language model. They can convert it to Python for you. Okay, there is no direct way to convert it into Python, and it would be very what do you call, it would lose its details because there are no Python equivalents. There is no Python SDK for this direct one-on-one SDK, right? So you will convert it, but I'm not sure how well it will work. You are much better off using it in TypeScript or in the n8n UI itself. Okay. Where does embedding a vector context attention mechanisms comes in which present current diagram? Okay, embeddings and vectors. Okay, if you're implementing RAG, you just need to know what a vector and what embeddings mean, not even in the sense what they are. You just need to know what they exist. That's all. If you are setting up a RAG store, if you are setting up Pinecone or any RAG store for an application, these applications will more or less handle all of that for you. You just have to write the simple code. Okay, so application of vectors and everything falls here, but that is the external application of vectors. Real application of vectors happen up here. Fine tuning. Okay, embeddings, vectors, context and attention mechanism are two different things. Context is like everything. Context is everything in LLM. Without context, your LLM is not even an LLM. It's just a text generation machine. It becomes a true LLM or a true AI agentic workflow when you give it proper context. Context is the leash that you use to control the LLM. Or other than that, it's a wild horse. It'll just run all over the place. So context does not fit into this definition. Context is a completely separate thing, which is a what do you call, what is context? You cannot point this is context because everything that goes into the input of LLM has to contributes to context. Context is a mental model which you have to create while thinking about LLMs or while dealing with LLMs. So context is not one thing. This is context. You cannot say that. But a embeddings, vectors, and attention mechanism falls here. Like this architecture, this whole architecture, BERT, GPT, they were based on attention. So jump from here to here happened because of attention. There is a paper from Google called "Attention is All You Need." A jump was a we were able to make this jump only because of that paper and attention. So that happens here, but vectors and embeddings, they lie up here. When you want to fine tune stuff, that is when you really will go into the model's architecture and read how many dimensions does this particular vector have or this model's vector have. What are the types of embeddings? What is the encoder? What is the decoder? How does the transformer handle them? How do I project these embeddings onto the resultant embedding so that I can use it for a different LLM or a different model. That is where it comes into play. This is the, like, it comes into the research kind of thing. Now this is not a hard, what do you call, hard slash कि हाँ यहाँ से इधर research, यहाँ से इधर application, यहाँ से इधर research. It's not like, it depends on your workflow. If your company dedicatedly works into fine tuning models, your research will fall here, right? For them, steering LLM or experimenting with new architecture may be research, but fine tuning is their whole job, so that happens to be their work. Okay, next question. Can we put quantization under fine tuning? See, quantization basically quantization is an optimization. Quantization is not necessary. Okay, quantization is kind of necessary because we have limitations on compute, right? So if you want, if quantization comes into play when, let's say, you have fine tuned a model, okay, and then the model has this big of a embedding. Now this is the limit of your GPU processor. It won't fit, right? So just to make it fit, you, what do, you quantize it into f16, f8, floating point quantization, whatever you, basically you're chopping off the data. Let's say, I'll give you an example of quantization. Let's say you ask me my address, okay, and you have limited amount of space to write my address. Okay, let's say you have a single line and I start telling you every single thing. I live on this floor, this particular flat number, then this is my pin code, and this is the what do you call, the landmark against which my particular flat happens to be. This is the lane number, this is the nagar, this is the state, Maharashtra, blah 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 blah. I give you all of this, and that won't fit into the space that I have, that you have to write, right? But this is my detailed address, this is what my address should look like. Then what do? That is when I quantize my address. I basically give you only the words which are important. I'll tell you that this is the lane number, this is the flat number, and this is the pin code. That's all I need to give you. From that you can make out, okay, what particular state might he be in, because I've given you a my pin code, right? That is what quantization means. Clipping data without losing the accuracy, or most of the time we do lose accuracy, but not to an extent where the model starts hallucinating. Yeah, if you reduce it to an extent like floating 16 or float 4 or anything, then you're obviously going to lose accuracy. But this is what quantization means, that you clip data or clip the precision of the mm, okay, now I'll have to get into detail. Basically all LLMs are neural networks. All neural networks have their small nodes inside the layers, and those layers are nothing but they are numbers. Okay, and the as we know, when you type a number, let's say I type number 19 point something something something, right? So in this number, this is our base number, and this is, what do we call this? This is the precision, or rather, much accurately, floating point precision, right? This is the precision. So let's say I give you three numbers out of after 10, I say this is, like, I have given you three precisions, like third order precision, fourth order precision, five order, six order. These can extend up to 15, 20, or even beyond that. We'd have zero idea. I have zero idea about how much numbers a particular model carry, but they are huge. And the CPU, then the processor that you have on your machine, it has a limit. It can only calculate numbers of this precision or this precision or this precision. So when your model has precision of, let's say, this much, and your CPU can only process this much, you literally cut this off and you work with only this. So obviously you have this much data.
We lose Parikshit again.
Anyway, we'll continue. So although you have I hope my screen is still being
Yeah, yeah.
shared, right?
The
Okay, huh.
screen, yeah,
Although,
shared.
yes, although you lose this much data, but still you get this much, and then you can work with it if that works for you.
No, sorry. Parikshit, I couldn't see your screen.
Wait, I'll just share it again. Okay. Okay.
Yeah, now it's visible.
So you lose some precision, yeah, you lose some active precision on your data, but at least you are able to run the model. Otherwise, if you do not clip this and try to run this, your machine will not be able to run it. But that again, that is an optimization we have to do it for our machines, right? If this is running in a cloud server, they have GPUs which can run this on full precision, right? So where does quantization stand? Quantization is an optimization technique. Where do I put it? Maybe here, maybe around here, right? It's not a part of research, but again, it's not also a part of application. It's a optimization done to run the model on our machine. But do we really have to run on our machine? That is completely up to us, right? Okay. So I hope that answers the question.
But if you, one, so quantization is basically to ensure it runs on low-end machines.
Low end devices, yes, that is what quantization is for.
Binary is basically we are adjusting weights and biases, right?
No, 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 no. We are not adjusting them. We keep them as it is. We just clip them. So let's say
Even.
there is a weight which is like
Hmm.
1.33333. We clip the last four threes and we only take 1.3 on runtime. And this happens on inference time.
Correct.
Okay.
Yeah.
Huh.
That, so
Although
during
there are multiple
steering,
methods. So huh?
so when you say inference, it means steering time, steering LM.
Yeah, yes. You can either clip it at runtime or you can pre-quantize a model, distill it into something, and then you can. Although clipping it at runtime will require enormous amount of compute, but again,
Compute
looking
again.
at the fact that you are clipping or quantizing the model because we don't have enough compute, quantizing it at runtime makes no sense,
Correct.
right? And it's a fairly new technique to quantize at runtime. That is done so that if the compute drops and then we do this, so that availability stays 100%, but not a feasible scenario. Most of them have enough GPU compute which can run it at full precision.
There
Only
was
only ludicrous models, like there are some models which I don't remember, but really huge models like DeepSeek or something like that. They are so huge, like mixture of expert models which have multiple expertise built into a one model. They are supposed to be quantized because it's not practical to run it at full precision, and they don't lose, like they maintain 99% accuracy even after being quantized. And there are level to quantization. On what floating point are you quantizing it? But again, this is like a completely research topic or like hyper optimization thing.
yeah,
In applicative and use cases, you will never have to come across floating point or anything.
there was a question about I guess context, right? So it was about embedding vectors in fun. So embedding vectors I can understand where the text processing happens, right? That's where basically what I say vectors and embedding. Context is more of for agentic, or is it applicable to chatbots as
No,
well?
it is applicable to chatbots as well. If you talk to an LLM, if you don't
Mm-hmm.
provide proper context, let's say you ask it, give me the recipe,
Mm-hmm.
but for what? Right? Or let's say you said, if you asked it, what should I make for lunch? It gave you a random recipe, but did you tell it that you are diabetic? Did you tell it that you had just eaten something before this? Did you tell it that what is your age, height, weight parameters, all of that?
Mm-hmm.
That is what context is. Context is basically steering your LLM to give you the output that you want.
So basically driving towards accuracy.
Yes. So the more find the context, and obviously you cannot just dump everything. That is
Mm-hmm.
garbage in, garbage out. You have
Correct.
to make sure you give precise and enough context. There is a sweet spot. So there is a graph for context. So if I have these two things, okay, detail, accuracy. So more context doesn't automatically mean more accuracy. Okay, there's a there's a relationship between this, which is like, okay, let me something like this. Okay, so there is this sweet spot. This sweet spot, you have to hit it. If you give
Mm-hmm.
too much detail, accuracy will kind of be like just enough, or maybe like if you go too much, if you give too much context, it and you overflow the context window of the LLM, then there's a sharp decline. It will start hallucinating like anything, and that is
Downwards.
unpredictable. What kind of
Downwards.
accuracy you will get, it could be like this or this, completely down the drain. Okay. And this is where the field of context management comes into play.
That's where
So
it
there are
stopped
different
us.
huh?
That's where it stopped us, right? It
Yes,
basically don't allow you to go beyond the context window.
context window. So what will happen? Context window is a sliding window. Let's say this is your conversation. Okay. This is your conversation. You talked about, let's say Paris up here. Then you talked about Paris here. You talked about Mumbai here. Okay. And some other place. You talked about Hyderabad here. Okay. And let's say this is your conversation. You are going around finding something, and this is the context window. Okay. This is the start and this is the end. This is usually 512K tokens. And this is calculated in terms of tokens, right? 512 tokens. Let's say as the conversation progresses ahead, and you're talking about it, if you don't context manage it, meaning you don't offload your findings to an MD file and then reload them, or you don't distill down, you don't compact. These are different context management techniques. You don't apply that, you just keep blabbering. After a point when you're talking about Mumbai, and now you ask, compare compare the results to what we found about Paris. If you say this, it will be completely blank. That what were the results about Paris? Because the Paris has moved out of its context window. Now, had you stored Paris into a MD file or a context or like a database or your vector database, it could be your vector database, it could be your MD files, it could be anything, any storage mechanism or a memory mechanism for it. Had it been there, so this particular query will trigger a RAG response and go back to the what do you call? Go back to the vector database or the MD files, whatever you have referenced, and it will bring Paris back into context, and then it will perform the result. That is a smart context management move. If you don't apply that, it will simply ask you what Paris. It will make up results sometimes.
Yeah.
Okay. So it's a sliding window. It will surely run out of, and uh, so there are different behaviors. Some LLMs keep it sliding. Some LLMs completely shut it. Like they will completely shut it and start a new window from here. They'll start a new window from here. So there are two types of behaviors. One is sliding window, which it will keep going like this, and there are some which will start like this and then completely flip on you. Completely flip. They'll start a new context window from here. So any and everything here was, and in any case, everything will be lost. But then again, that is where context management comes into play. So context is not one thing, like this is context. You cannot point at it. As context windows grow to 1 million plus, will RAG become obsolete and will cost and latency keep it relevant? Okay. Context window growing to 1 million is a hoax. Okay. No context window has reached 1 million. When actual models had 51212K context window, that is when Gemini had 1 million context window. But that was not how they did it. What they did was they offloaded the context management from you to them. Their servers did context management. That's why you were able to use 1 million context window. Okay. True 1 million context window would require an enormous amount of model space. And that is not practical for anybody. So these 1 million context window claims are, maybe they have done model optimizations and practically and theoretically it is possible. But 99% of people who serve model as a service, whoever have their models hosted for you to use, they will not have models perform 1 million context on its own. They have context management built on their servers. Cloud Code caches your context, it caches your system prompt, it caches your code base search, it caches all the vectors it has created, it caches the files that it generates. Everything is cached. So the mechanism to manage that context is taken onto their servers. But if you are building an API, you are building an application using API, that will not happen. You'll have to manage the context yourselves. Okay. And it at max, these models can manage general context. They will not be able to curate to your specific context. That you'll have to manage yourself. Okay. Let's say you generate a plan to migrate your particular application to let's say new version of Next.js, right? The
Hmm.
machine or the servers will have context to your project, but they will not have context to what you want to do right now, right? That you'll have to manage yourselves. So context management is issue. Also, one reason for agents and their skill sets and tools, like for example, we create a specific agent in GitHub Pilot for repetitive tasks. So context management issue is also one reason for the agents and their skill sets and tools, like, I didn't quite get you, Sandeep.
We can unmute as well if someone you
Ha,
want to.
Sandeep, you can unmute and you can
Yeah.
talk. No problem.
Yeah, okay, sure. So I was asking, like, while creating the agents in GitHub Copilot, right? So we create .md file for skill sets, their tools, what they can use. So if we
Mhm.
talk it into Copilot agent, I think it gets like sliding window goes beyond there, and I always wonder why it is not understanding, which I told it like before, and
Correct,
that's
correct.
why I think.
Yes, yes, yes.
Okay.
Yes, that is what happens. So if you look at, if you use Cloud Code, go to Cloud Code, or any other AI assistant you have available. If you go to Gemini, Codex, Claude, anyone,
Mm-hmm.
the new thing you'll find since last 6 months is a memory.md file. Every single one of them has it. Okay,
Okay.
what
Mhm.
and you can look at it in your settings. So let's say if I go to my documents settings, this is my Cloud Code settings. So there has to be a memory preferences. These are memory preferences. What they do is they manage the memory for me. Search, this is memory from my chats. What this does is it takes all the chats that I've done with it from all the periods of time, and when I'm not using it, it basically creates new memories out of it. So that, see, this is the memory that everything that it has generated based on my chats. Yugan is the founder of Yugan Space, a startup building proprietary geospatial AI. My personal contracts has interest in Android development because at some point I might have done Android development, right? A family member is a licensed pharmacist. My father happens to be a licensed pharmacist, so that I might have asked something about it. Top of the mind, actively building Yugen space context enrichment layer, catalogs 190 plus API, 30 intelligence categories, blah blah blah, and then all of these things. That it is learning based on what I do. Right. This is how it
Okay.
is managing context for me in a global context. Like it is doing it in global sense. Every new chat I open will be using this memory file to see how I like things and how I prefer things. But for a particular chat, like an individual chat, it will not keep context of that for like infinite period of time. We will have to manage it ourselves. So to do that, what current Claude bots and everything have started doing is they start writing MD files. What they do is they prefer writing files. So okay, I have found this thing, I'll write it to a file or write it to disk, so that
Okay.
later when I lose
Mm-hmm.
it knows that I'm going to lose context, I'll bring it back. So they expected us to do it, but like we don't do it that good, so that's why they do it themselves.
Okay.
Okay.
Okay. One question
Okay, so
related to
suppose, yeah, sure,
that.
sure.
So, what is the main purpose behind creating the agent? Then means I am not. Is if we are getting all answers from like
LLMs, why do we need to
LLMs
create
and
agents? Okay.
agents, yeah.
So LLM and agents. LLM can have a memory, right? LLM after memory having tools, and Ralph loop is an agent. So why do we need agents? Agents with LLM and agents are not two different things. LLM with capabilities is an agent. If you don't want capabilities, you don't need an agent. If you only want to talk to it and have it remember what you said and what you asked, that's all. You don't need to have an agent. But if you wanted to do things on your behalf, if you wanted to run unattended, think about its action and take more actions, then you eventually are dealing with an agent, right? If you don't want
Okay.
that, you're talking to an LLM. If you wanted to take actions, if you wanted to call tools, if you wanted to remember things, then you are inherently talking to an agent. It's a very thin silver lining.
So
Okay.
basically, LLM is thought and the agent is action.
LLM is the brain. Yes,
Yeah,
LLM is the
same,
brain. If you
same
cover
thing.
it in a body which can do things and remember things, you have an agent.
Got it.
Correct.
Thanks.
Yeah. Suppose I'm running a LLM locally, can I apply quantization dynamically like according to query 4 bit for small query and for 8 bit less? Uh, you are better off not doing this at runtime, because the fact that you are running a LLM locally and want to quantize it, you have limited compute, correct? First of all.
Hardware.
Second of all, huh, second of all, if you want to do it, take the model, base model, considering it's open source, take its weights, quantize it, either using LoRa or using QLoRa, whatever, however you want to do it. It's a simple transformers function, Python library, install it, run it, or even available in JavaScript, doesn't matter. Quantize it, take the distilled model, create both 4 and 8, host both 4 and 8, and whatever is your inference logic at runtime, based on the query, divert it to whichever model you want. Okay, you cannot do this whatever you're asking at technically runtime, but you can divert the query to whichever model you want at runtime, given you have both of them running. But again, it returns back to the same question, that you have limited compute, and will you be able to host 8 and 14 bit both quantized at the runtime? Not sure. Okay, I have heard that LM use 6 to 7 types of memories, like temporal memory, permanent memory. That heavily depends on the model and how the proprietary company has, what do you call, okay, nice, how has they maintained it, and if they choose to make it like make it a thing that you can read around or not. There's no particular way to go around and you see what type of for the expose. So for example, I show you cloud code memory management, right? It remembers things about me, it remembers my preferences, and they show it to me in an MD file. That is what I can see. But what they do on their servers, I know that they prompt their that the cache system prompt, because it's a very general thing to do, because system prompt is sent every single time when you invoke an LLM. That has to be sent every single time. Tool calls are not cached, APIs are not cached, keys secrets may be cached depending on what are your preferences, right? So there is no, it heavily depends on the type of model you are dealing with, and if the company chooses to open source that information or not. To be very honest, there is no inherent memory management in models themselves. They don't have any context regard, or I mean, sorry, they don't have any business doing that. The whole job of LLM is to generate text. It is a GPT, generative pre-trained transformer. It is pre-trained on lot and lot of data. That's why it's called large language model, and it is a transformer model. So it can take your language, convert it into vectors, inference it, report vectors back, and convert it back into your language, whichever language you want to have the answer in. It has zero business doing memory management and remembering what it generated. It is like asking the ATM to remember how much money it gave me last time. It has no business. The bank is supposed to manage all of that, right? ATM has zero clue what it did. It just does that. You enter pin, you give your card, it drops off the money. That's it. It has zero business remembering which user took out how much money last time, this time. It doesn't care. That whole management system has to be deployed on the bank side, or in this case, the LLM provider side. So Claude will implement different types of memories. ChatGPT might do it differently. Gemini might do it differently. It heavily depends on the company. Okay.
Actually, foundation models doesn't know even about context.
No,
They,
like they, context is what we have created.
right.
Context is what matters to us. Let's say I ask it to generate a recipe. It generates a recipe. According to it, it's a correct recipe. According to me, it's a wrong recipe because I have diabetes. Right? Why, what decided if the output was correct or not according to me matters to me is my context. Somebody who is not diabetic is completely fine with that recipe. So a similar response from LLM for a similar query is correct for somebody and not correct for me. Based on what? Based on context. And context differs. My context will differ, somebody else's context will differ. This context things is very dynamic according to us. And in terms of LLMs, we are supposed to manage that context. It could be your code context, it could be your project context, it could be your preferences. If you like functional programming, if you don't like functional programming, if you like to use if, or if you like to use if not. These are my contexts, right? Based on that, I'll judge if the LLM is providing correct output or not. But that correctness is determined by my context.
Makes sense.
Okay. Any more questions? So coming to the point, like this is the graph of everything, and we will be dealing here in L1. We will be starting with this part.
Parikshit, your
Not
WhatsApp
even
is
this.
displayed.
Huh? Okay. Is it? Oh,
Yes,
I thought I was sharing. ठीक है?
no, we still now it's yeah.
Perfect. So in this, acha, makes sense. I changed the monitor, right? So what was I saying? In L1, we'll be dealing somewhere here, around this space. Okay, around this space. Okay, this is where we'll be dealing. We'll somewhat touch LLM, lang graphs, and everything. Somewhat we have already touched on n8n, right? We'll explore a few more in L1, maybe if required. I think n8n is more than sufficient, but we'll go into applications, and to learn applications, lang graph, langchain, ADK, and blah blah blah. You need to know fundamentals of LLMs. So that is what we'll be studying. These will be only with the modus operandi to get used to them. But other than that, we'll be doing this and somewhat of this because even if we are a developer, we need to know different ways. Oh, just a funny thing like a update. So we need to know how to use this browser based API to a certain extent. Let's say you're going through a code base. This is really funny. If you're going through a code base and you want your LLM to be very serious about it and find what do you call exact flaws. Let's say you are on a front end code base and you have randomly scattered CSS files or randomly scattered what do you call inline styling sheets and everything. You want it to find everything and not be a yes buddy. Most of the times your LLM is a yes buddy because if you ask it, is it right? It will say yes because it does not want to do it goes for the least frictional path. Okay, it is right. Unless you ask it to specifically look it on the file, then it will say, oh, yes, yes, this was wrong. So write your prompt and tell it to be in a bad mood. Ask it, go through the front end course base, fine, blah, 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 whatever you do. And at the end, just add one line. Be, behave like a veteran developer who is in a bad mood and goes according to text. I bet you it will find 5 more flaws than it will without this line. Try it. Just next time you are using some coding agent, try this and see, look at the results for yourself. That is one. And second, when a LLM generates a response, that is not the only response it has generated. It has 15 to 16 responses which are ranked based on, can somebody name it? Expecting a bit too much, but
Probability.
probabilities. Perfect. So it is based on probabilities. Ask it in the end of your prompt, give me all the give me top 3 probabilities. What that will do is it will completely take the load off of LLM because most of the time it has came up with the right answer, but it is ranked second or third and something has taken precedence due to some bad context or something or the other, and it gives you that response. That causes the issue in you having a bad response. Then you ask it, "Arey, nahi, nahi, this is not what I asked. This is what I wanted," and then it tells you, "Yeah, yeah, this is what it." And why did it get it right the second time around? Because it had the answer all along. That extra push, "Nahi, nahi, this," gave it the gave the extra points to the second probability for that to be the answer. So rather than this round trip, ask it, give me top 3 probabilities. What that will do is give you the 3 solutions that the LLM has come with, and then you are responsible for choosing out of it, because that is what matters. According to your context, which one is right, you choose it. That brings a lot of pressure off of the LLM and it behaves a bit better. So these are the simple prompt techniques which you can use to manage the LLM better. So this is where we will have L1. Then this is where we will have our L2, like heavy, very heavy fine what do you call this, math, not okay. L2 will be a mixture of whole of this and some of this, not mathematics. This is going to be a completely different L3. Okay, mathematics and all of that L3, but I can take fine tuning in applicative process. Okay, applicative process, fine tuning, and model infra, transformers, architectures, just to know. And this is the applicative layer. Okay, we're not going to know how to build a GPT, how to build a BERT, how to build transformers. No, we're going to know what they are, how they perform, and how just the linguistic characteristics of everything. Please repeat the live stream poem that you just said. Okay, what I told you was, first ask it to be in a bad mood. As soon as you ask it to be in a bad mood, it stops joking around, it stops being very lethargic about the code. It goes deep into the code and finds the issues. I have observed it. I don't know why it does that. Maybe training data or something like that. Somehow it just does better for me. And I'm specifically talking about Claude. Claude does behave better when you ask it to be in a bad mood. I don't know about others. Secondly, ask it to give you top probabilities. Let me wait. Let me show you. This one. Okay. This is a simulation of how a LLM works. Okay. This is, oh, come on, load. This is a simulation of how an LLM works. Okay. We don't have to go into depths right now, but this is the embeddings. Embeddings are formed from the question that you have asked or the prompt. That prompt is converted into the embeddings. Those embeddings are then taken into transformer blocks. This is the core architecture transformer. It does query. This is where your attention comes into play. Then you get the output. Then this is like the projection. Everything happens. And then if you look at this, these are probabilities, right? Well, the first answer visualize got 54% probability. Second create got 20. C got 12. Make got 6. So whatever the prompt was asked, this is a completely different thing. I'll have to explain it to you later. Okay. This
Already you
this
started showing 11 candles for free.
actually. So this thing anyway, that doesn't matter. So LLM is nothing but what do you call what is that thing called when you're typing on your keyboard and something predicts, what is it called, auto predict, autocomplete, autocomplete on steroids. So LLM does nothing differently. All this thinking, reasoning, blah blah blah, it's all just created terminologies. Everything is in the core of it is an auto guessing mechanism which guesses your next word based on probability. So let's say you have written this much: data visualization empowers users to, and what would be the next thing? It could be visualize, create, see, make, easily, quickly, blah. All of these are these are anything beyond zero is a valid output. Users to easily is an very plausible output. Make is a plausible output. See, create, and visualize. Out of that, visualize has made the most points, and that's why it is going to be visualize. And whatever comes next, we can click generate, and the next word will be predicted. Now, this is the exact mathematics how, but let's not get into that, or we'll spend like 2 days here. Okay, so what LLM does it just guesses your next word based on this context. Based on this context, so to generate visualize, it took data as context. To generate empower, it took data visualization as context. To generate user, it took data visualization empowers as context. And out of that, this is what the model thinks. But let's say I, the user, wants to write create, then according to me create should be the right answer. But will that surface? No, because the LLMs are trained to give you one and one output only. Or the word that particularly fills on the next space can only be one. There cannot be multiple words, right? So according to it, it thinks visualize. But what if I write this particular prompt and I ask it, give me the probabilities, give me the top 3 probabilities? At that point, what it will do is it will give me visualize, create, and see. Then I can choose which of these takes precedence, because all this percentage, these are allotted because on some random mathematics which does not belong to me or my preferences, unless I have managed context very properly. Let's say you manage context very properly, this mathematics will completely portray what your preferences are, and it will come out with the correct thing that you want. But unless it has seen 15-20 examples of what you want, it cannot do that, right? And when you give it those examples, these are the things that it changes or like manages. All these weights right here, all these weights that you see, they are managed, right? And that is basically what fine tuning means. But again, coming down to this part, just to make it behave a bit better, you take this load out of the model's responsibility. You ask it, give me the probabilities and I'll choose. Okay. And when you do this, it gives you the probabilities. It just doesn't bother about choosing one best out of all of this. It gives you all the probabilities and you can choose your particular answer. Okay.
Seems like it is applying k-means algorithm.
Huh?
Seems like it is applying k-means algorithm. GPT-2.
Yes, k-means. There are different types of
K-means. Yeah.
k-means. Like there are top k, top p, and like if we get started, we can. We can
So these should be different for different pre-trained transformer, right? So
yeah. This is the oldest model. This is the
correct.
GP22 model. This is like one of the oldest models. Like one of the not I won't say one of the oldest, one of the publicly uh, preferred models to understand attention. I would, if I were to do it, I would do on original Google's GPT
Yeah.
implementation, even
Yeah.
one before this. That is even more simpler to understand because there are a lot of what do you call extra processing happening up here, like multi-headed self-attention. I don't want to get into multi-headed self-attention unless I know self-attention first, right?
Yeah.
Multi-headed splitting, mass self-attention, like it's a rabbit hole. If we start here, it's going to take a lot of time. Anyway, I think somebody raised their hands. I don't know what for. Did
Uh,
somebody?
I had one question. So when GPTs and these LLMs come in like publicly, so there was the statements they are telling that this model can solve the JE or NEET exam like questions for that exam, and this model
Hmm.
scored these marks out of 720 or 360. So but how many of us have this experience? I don't know, but I have experienced that when we are asking a MCQ question, multi choice question to a model, then it quickly
Hmm.
answers the question, but uh, if we tell that this is not the correct answer and this is the correct answer, then it has to think again on that, and it tells that absolutely sorry, this is the reason behind the correct answer. That, so why would this happen? Are we supposed to provide the context here also, like if we don't know the context for that question?
So here the problem is you are asking it something that we don't know. Let's say you ask it a multi-choice question which you don't know answer to,
Yeah.
correct? And you want it to solve it. Now it heavily depends if the model has seen that data before or not. Large language model cannot cannot generate data which they have not seen, or not generate the type of data that they have not seen. They can mix data, they can translate the data for you, they can learn patterns and then have different words mapped in those patterns, but it can only generate patterns and things which it has seen, which was in its training data. If a particular thing was not in its training data, there is absolutely zero probability that it will generate anything like that. Let's say you trained a model only on things in what do you call, in Python, only on things in Python, correct? And then you ask it to write syntax of CPP. It will not do that unless the language training data had some CPP in it. If you like make sure that a model only knows, it has no zero context of language, it cannot talk English, it cannot talk any other language, it can only talk in Python, and it will only generate Python data. It will never be able to convert that to CPP, right? So models are limited by their training data. So when you ask it a multiple choice question, it heavily depends whether it has seen that type of question or enough data about that question or not. And plus you're asking a direct question, you're not giving it enough context. How do you want it to answer? But given it's a MCP, like multiple choice question, it is very difficult for you to provide context because this is not some specific context, it is a global context where there is going to be a single right answer, and for everybody around here that is going to be the answer because it's a proven fact, right? It's not something your choice determines the answer on. It cannot be like, if you ask it an MCQ question saying what color do I like, then the answer heavily depends on you. But if you ask it what is the boiling point of water, the answer has to be 100. It cannot be different, right? And it heavily depends whether the model has seen that particular question or not. So is it hallucinating? It depends. Hallucination is okay when a model generates data, or when a model generates response which contradicts a fact, that is hallucination. If it generates something which is not a fact, it is not hallucinating. So if you ask it what color do I like, and if it says green but if you like blue, that is not hallucination. That is context mismanagement, right? If you ask it what is the boiling point of water and it says 0, then it is hallucinating. Okay. All right. Also, one more thing. Why do you have to ask it again? That is the inherent nature of an LLM to answer you every single time. It cannot say, I answered you already. It cannot say, I have just given answer to you before, I cannot change that, blah, blah, blah. Every single time you run something, it has to go through that invocation loop and it is determined to give you an answer. And to do that, it will go to an extent to make up facts, regardless if they're right or wrong. Because these, like, gets into some metaphysical questions whether if these things are right or wrong is our context. This is our world. We determine them. We defined mathematics, physics, blah, 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 blah. And these are our constructs which define whether a certain thing is true or not. All of this does not exist in the vector space of the model. For it, everything is right, everything is wrong. It heavily depends on what you teach it, right? And that's why there is no intelligence inside these models. It's just a made up hoax terms, artificial intelligence. Doesn't matter how intelligent it gets, it's still artificial. And the fact that it's artificial makes it hallucinate. It will always make it make up facts which are not right. And it has to give you an answer. It cannot stay numbum. You type something and nothing comes out. That completely breaks the LLM. It has to go through the cycle of response and request. So it will always generate a response regardless if it is right or wrong, and it will always keep doing oh this and oh that and that, blah, blah, blah. Yes.
Just I wanted to understand the overall perspective. So my means you can correct me. I'm just saying my mind. Like if suppose I go into back into 90s, then Google came. So we are just understanding Google as they have created some database and they have some smart queries. Like we are asking some queries and we are getting the knowledge. So sorry,
Right.
data. But when these LLMs are coming, so they have marketed like OpenAI has, we have a smart brains, suppose, and kind of like you, if you want something, we can give you a processed data or we have some knowledge. Means the marketing, they have done something like that. So does they have their database or they are still using some other database, or is it both like some common things they have created into their database, and for some latest news they're using Google's and other.
Okay. For this, you have to get into the part where you create an LLM. How do you create an LLM? The first thing that you have to do when you create an LLM is get data. Get lots and lots of data. So there are two ways to look at an LLM. One, it's a wait, it is auto. What do you call it? Auto fill, right? Auto guess, auto fill, whatever you have that
Auto
on your
completion.
keyboard when you
Auto
auto
complete.
complete. Correct. Auto clip, auto complete on steroids. Okay, so it's an autocomplete which is amazingly fast. It can complete sentences and sentences. That is one way of looking at it. Second way of looking at it is a compression mechanism on steroids. Now let me ask, Kuldeep, do you understand the term compression?
Yes, like
Okay.
means
So
compression
let's say there
means
is file. Let's say there is a file. If you want to compress it, what do we convert it into?
either zip.
Zip
Yeah.
file. Correct. What do? We compress it into zip. This process is called compression, right? This is the most common form of compression we know. This is on the file level. This is what we see every single day. Other type of compression. Let's say there is data. Okay, there's data, and all of these have some different value. Let's say this has one, uh, 1, 2, 88, and 65. I'll put this, I'll put this, I'll put this, and I'll put this. This is data. Now, how do you compress data? Compression of data takes, and there are algorithms. Okay, they are called compression algorithms. The most simplest one I'll tell you. I will not explain what they mean, how they happen. I'll just tell you the logic. Okay, what they do is, sometimes let's say I want to compress this data. So how much space is this taking? 1 2 3 4. Let's say 4 units of space is taken by this data. Let's say these are some color values. Okay, RGB and A. Okay, now I want to compress this. What I'll do is I'll take two spaces up here. Okay, I'll add how many blocks of data were present, how many were there, 1 2 3 4, and then based on 2 I'll save an expression here. What I'll do, I'll not save a number, but rather I'll save an expression. So this has to be 2, right? 2, then comma, I'll do is I'll take this as n and I'll call it n equals 2, and then I'll get it n. What is 8? Next number is 88. Let's make it 64 just for the parity. Okay, I'll save an expression. This is 88, so I'll save n comma 44 comma 32. Okay, I obviously this will take me a bit more space compared to a single unit, but the benefit, it will obviously take 1.5 times the space of a base unit, but obviously what it will help me do is let me save a expression. This took me 4 units. This is taking me 2.5 units. Right? Data, what does compression has to do? It has to reduce the size. It doesn't matter how. And what did I do? I saved the relative configuration between the next set of data. I know how many are there. 4. What is the first one? 2. Second has to be 44. Third has to be 32. And I know that if n is 2, this has to be n44 and this has to be n32. And when I evaluate this expression, that which means I will decompress the data, I will get this, right? Do you get this much? Understood this
Yes.
much? Right?
Yes.
So this is the common compression that we see, and this is the file level or data level compression that we see. Okay. Now, looking at LLM as a compression, all these algorithms, they use smart things, smart algorithms to compress data, right? LLM does something same. What you do is, and okay, now let's say you compressed a lot of data, but these algorithms, whatever do this type of logic, they cannot search through data. Can they search through data? No, they can only compress data and decompress data. Then after that, you are responsible. Let's say you have stored a lot of data up here. So what is a place where a lot of data is stored is called a database, right? You have stored a lot of data, but through search or through query through that database, you have to implement your own query engine, right? You have to manage that. This could be SQL, this could be MongoDB, blah blah blah, any type of SQL language that you have, right? So this is your query engine. Imagine an algorithm which does this at 99% accuracy and has a built-in query engine. This is for the database engineers, how to look at LLMs. LLMs are nothing but compression and decompression algorithms which inbuilt query engines, and that is what it means when I say a compression mechanism on steroid. So what happens is, you take a lot of data. Okay, you take a lot of data, formatted data. Yeah, you take a lot of formatted data, you put it through a lot of blah 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 algorithms, and you get something. Now this, what is this? This is an LLM. Now why is it special and different from other compression? Because this could be in petabytes and this would be in GBs. That is the compression ratio. So the compression ratio here was 4 divided by 2.5. However it is matlab, some 1.985 something like that, right? This much. And here the compression ratio is almost 100x, almost. And the added benefit is, this LLM can generate or search through that data. When you ask it something, tell me about a pond, what it does, it goes back into its memory, the neural network that it has, and it generates that data, right? Whatever the patterns it has learned, whatever the things that it has learned about pond, and it generates blah 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 data for you, right? Again, data. So what you did, you compressed petabytes of data into GBs, and then you have an inbuilt search engine, which is basically a vector projection. Vector projection, just keep that term in mind. This is the SQL query equivalent of LLM. So when you pass a prompt, what happens inside it? Vector projection happens inside it. How it happens, when it happens, where it happens, we'll take a look at that in the L1 course. But this is a different way of looking at it. So now coming back to your question, what Google did They generated a lot of data, kept it on a database, and then when you searched it, they fired a query, and the query engine found that data and served it to you. That is what Google did. What LLM does, LLM is trained on petabytes and petabytes of data, and you have an inbuilt vector projection. What do you call query mechanism? You give it the query that you want, just like you give the query to Google, flats, and then it gives you flats. But again, you have to provide context. Flats in Pune, then Google gives you flats in Pune. Same is thing with the LLM. You give it some sort of input, it goes into its neural networks. Although, like, it has compressed it into GBs, so obviously there is a risk. Will it generate absolute perfect data? That is the reason you have to generate a proper query, and for this part, query is called a prompt. So as good as a query is to a database is the prompt to a LLM. Is that understood?
Yes. So means
So these are two. So there is no database stored somewhere, or rather the LLM itself is a database which has all the data it has been trained on, and a query mechanism built inside it. Right. So they don't have to host different APIs like Google has to for search engine. They have a big database somewhere, and word to correct. So it doesn't, they don't have to host a database and then have a query language on it and then perform queries based on user query and then serve you. LLMs don't have to do that. LLMs can have all of that data compressed into themselves based on neural networks, and this is smart compression. They learn patterns. LLMs don't learn raw data, they learn pattern, and that is the very reason LLMs need formatted data. And this format is determined by the LLM schema or vector schema. So how many dimensions does the particular vector of that LLM has? How are they determined? How are they linked to each other? That determines the schema. That is how the data has to be formatted, and that is when you can generate a LLM. And it basically has all the patterns and all the things that it has learned. It knows the biggest um power of the LLM is that it has learned the patterns of language. Google does query matching. It cannot tell the relation between those two. It can simply do two different queries, join them, adjoin the query, and dump it. Flats in Pune. It does not understand what in means. It says flats Pune. That's it. Simple. But LLM, flats in Pune, it does understand the meaning. Why in came after flat? Why was Pune not before? Pune in flat. Why would that be wrong? If you can test this. Tell an LLM flats in Pune, Pune in flat. It can spot the difference. Okay, this is wrong grammar. Go to Google, ask for flat Pune, Pune flat. It will give you the same results. That is the difference. LLM understands the nuance or the patterns of language and of grammar. That is the big difference, and that's why we are more naturally inclined to our LLMs, because we can talk to them naturally. We don't have to define everything very strictly. That gives us the flexibility of thinking broadly. Correct? So there is no hosted database and they can give us data from anywhere. LLM can only give us data from the data it has been trained on. Training data set. Okay? Got it?
yes. Thanks.
Okay. Okay. Then I think we should stop today. Mohit,
Yes, I
have you tried
think
the new Microsoft agent? They have dev UI swagger like thing where we can see the flow like n8n visualization. See, my problem with these new workflows is not that they have more features. n8n had these features way before all of this did. And Microsoft being a $1 trillion company, I expect more from Microsoft. Right? Their first Magentic One SDK, I didn't. They're not adding true true to the work feature. These are like quality of life feature. I'm being able to see the docs, swagger like docs and tools and everything. These are quality of life feature. Are they making context management features? Are they making what do you call vectorization features? Are they building new vector stores? Are they building compression mechanism for those vector faster retrieval queries? Anything like that? Adding those kind of things to a particular frameworks makes it a rich framework. These things like these are just quality of life. Why is it always related to vectors when it comes to AML, vector projection, vector database, vector schema? I know I convert everything. I know it converts everything to vectors. Yeah, like you answered the question itself. LLMs works on vectors. So when it started, we were hell bent on making machines understand language. Like this is how L1 is going to start. So we started with machines who talked binary. Then we made them talk assembly. Then we make them talk some high level functional languages. Then we make them talk into Python, like C programming languages, Rust, and all of that. Then we make them talk into even better languages like Python, which were forgiving. At each level, we have been trying to reduce the complexity of us talking to the machines. We want machines to understand us, because the master slave relation that we have with machine inclines us that machine should come towards us, not us going towards machines, right? So at every point in technology that has come forward, we have been trying to make machines come to our language, not us going to them. So eventually, we wanted them to understand our language. The biggest issue was every language before this had a specific construct and specific rules. Syntax is what we call them. A rules in language is called syntax. This has to be done like this. A function has to be written like this. A data type has to be done like this. XYZ, XYZ. These were the rules. And we learned the rules so that we can command the machine. But we did not want to do that. And we wanted machines to learn language. Now, the problem with language is there is no defined rule. Flat comes after Pune. Flats in Pune. Why does in have to come in between there? What does in mean? Who defined in? Is it globally accredited that this is the only word that will be used for in? Then why does inside exist? Why does under exist? Why are there 10 words for one thing? And that was the complexity with the language had so many different constructs, same thing for different meanings, same meaning for different things. That was out of compute capabilities of our machines today, and we were not able to solve this. And this was a problem faced back in 1990s. And AI, we are hearing about AI today. This has been going since 1960s. But they were trying to solve this problem, that how do we make machines understand our language? We could make them understand assembly, Python, C++, because we defined the rules, and nor us nor machines could go against the rules. That's why we had a parity. Now the problem is, I have one language, my friend has another language, somebody has different language. There are billions of languages in the world, and who is defining and or who is managing those rules of the language and saying, "Nahi, ye aisa hi hoga, wo waisa hi hoga." There is no central authority to this, and that was the problem with language. And that is when we gave up on brute force compute. We cannot brute force language, at least with the type of compute we have. Quantum computers maybe, but today's binary computers, they cannot. Even if you make it like ternary computers, which was a thought back then, okay, let's make computers ternary, but it added only extra complexity, and it was a hell to manage. So, and it did not solve the problem as well. So we left on brute forcing the language. We could not teach machines language directly by if else. So if flat exists in the first, then the next word should be Pune. Then the next word would be this. If we would try to compute these many calculations for a single word, it would take you one whole day just to guess a single word. That is how big the construct of languages. That's why we moved to probability. And it has been a well-known technique in mathematics that when anything cannot be guessed with absolute precision, use probability. That's the reason why this speed and the momentum and position of an electron is measured in terms of probability. It can never be measured in what do you call the exact units, because we don't have enough precision. We don't have enough fast instruments such that we can detect the position and tell them at the same time, right? That's why we use probabilities. And it has been a very common knowledge in mathematics that when you cannot do something very precisely, use probabilities so you can get just good enough answer. And that was always good enough in mathematics, and that's what we applied here. We created a probability generation engine to understand language, and we trained it so hard that we brought the probability percentage to 90 to 99%. And that's why they seem so good. The remaining 1 to 10% is what we call hallucination. And to do this, we needed a data type which could expand and contract and move in n dimensions, because language has, our physical world has 3 dimensions, x, y, z, or height, width, breadth, as we call them. Colors have 3 dimensions, RGB. And like light has different dimensions. For us to be able to put language into a construct which can be computed, we had to have infinite dimensions, because language grammar has infinite dimensions, right? Why does this have to be after this? Because a dimension defines this. And to map all of that, we needed tremendous amount of dimensions, and no other data type than vectors was able to do that. And that is why everything inside MLs and AI depends on vectors, because vector is a what do you call, a very dynamic concept. Vector can be 3, 4, 5, 6 dimensional, doesn't matter. We have the infinite limit of creating dimensions in vectors, and that is why we use everything Everything regarding AI and ML is in a vector because. Okay. Sorry, I cannot see one new message. Last question.
Uh,
How they calculate tokens, input and output, how they combine providers charge. Token token is a biggest hoax or biggest lie of 21st century. There is absolutely no reason for a company to calculate your usage in tokens. There is no math which tells one token is equals to this much amount of electricity burnt in the GPU and the servers to give you this output. There is no way to map it because one token can be 3 words, 4 words, 5 letters. It can be anything depending on the token schema of the model. So how they calculate is completely dependent on how much profit they want. It is as simple as that.
Parikshit,
Token is just a made up.
what I was thinking is maybe
Huh,
we should add to set up Queen or any small models on their system
huh,
and expose
huh.
those to Cloud Code or something like that. So
Sure,
and
sure, sure,
that
sure.
way,
We can do
that
that.
way, this question is completely out of context.
Correct. We can do that.
And just to add more on this, the language part. So uh, take the real world example. For example, what Parikshit was talking about is semantic or symbolic machine learning. So symbolic means where we have the world of rules and logic, right? Now challenge is if I would like to represent a chair, my simple rule would be four legs, a base, right? That can be chair, stool. So it can identify chair or stool. But what if I show bin bag, right? Bin bag is also chair, or there is a round chair, right? And these things basically start breaking that symbolic AI, and that's where approach is changed. Basically, this is mind shift happen where going from symbolic to figure out the algorithm based on data. So rather than we tell rules of the language, basically we are telling the data, and this data is n dimensional. That what Rishi is talking about. Huge amount of data set, and based on the data set, machine is identifying the pattern. Please correct me, Rishi, if my understanding is have any gaps.
No, correct. Perfect. Makes sense. What is the L1 course? L1 course is exactly what I was talking about till now. Everything that we talked about in detail and more on these language like the lang graphs and all of these, a few hands-on sessions. Mostly for explainers, I'll use n8n because hands down it is the best visual representation and the combination of visual representation and control that you can have. Next, we'll have a few implementations of these RAG, different implementations of agents talking to each other, multi-agent orchestration, just overviews, but that we'll push to L2 as well, heavily detailed. And then in L2, we can go on models, the infra, transformers, architectures, how to use them, then a bit of fine tuning as a final project. And then finally, if at some point we do really reach an audience who is interested into this, then we can go into the proper mathematics behind the okay. That will the L3 will be heavily dependent on the response. I'm not guaranteeing that I will take L3. I need substantial people to enroll for it for L3 to be L1. I'm okay. L1, any number can come, I'll take. Even if a single person sits down. How much will be a duration? Okay, that's a really good question. Although I am not giving you a word that this is the exact thing, but my approach toward is that key people nowadays, like the life nowadays is very fast. You are expect in the industry nowadays is very fast. Coming from a developer perspective, industry is very fast. Every day 5 new things are popping up and it's really difficult to keep up with all of them. And the plus, when you don't know the underlying mechanics, it really creates a havoc in your head that okay, I don't know this much, I don't know that much, and then anxiety triggers. I don't want that to happen, and I don't want to take a lot of time from you all. So I am thinking on terms of making it a hyper fast batch. So maybe like a week of dedicated 3 3 3 hour sessions, or maybe like a weekend of 6 hour sessions each. Sunday for Saturday 6 hours, Sunday 6 hours, done. 12 hours done. Or we could split it into weekdays, 3 3 3 3 3 12 hours. However, I will put out a poll on the group and we'll decide based on people's preference because I'm experimenting with this. But one thing is for sure, I'm not going to extend the batches beyond 6 months of any kind. Even L3, it will be max 4-5 months enough. And that too because it contains that much depth. And L2, maybe a month, max 3 weeks. That's it. Because I want, because if I am teaching you something today and it becomes outdated in the very next week, we all lose interest or we all lose incentive to learn that. Because I know nobody here is like ultra passionate about AI. Because if we were ultra passionate about AI, we would be some research fellows or something out there, right? We are here to cater the industry. That's why this applicative layer is more lucrative to everybody, right? So we want to focus on application, something that we learn today and are able to apply the very next day into our work. Let's say you have an interview tomorrow, you should be able to learn it today and apply it tomorrow.
Yes.
That is how fast we want it to be.
Whether L1, L2 would
So,
be that kind of platform where you
yes, hyper fast,
come
hyper.
quick, adapt, and apply. And then we
Correct.
will see the passionate people in L3.
L3 would be a what do you call? I am 100% sure only people who I see people who are working with neural network mathematics and fine tuning LLMs. They don't need to enroll for a course. They are if they have reached that level, they themselves can figure everything out.
Correct.
But if somebody is enrolling for L3, I am 100% sure they are inherently curious about it, nothing else. And if curiosity is something that is driving to you to a course, then that is not a course, that is going to be a discussion bench. We'll have good discussions for 3 months, because at that point you're not thinking about, can I apply it in the job, can I apply it in the market, will it fill a spot on my resume? That happens in L1 and L2, and I can understand completely. No issues with that. I mean, I did it. Everybody has to do it. I understand the dexterity of the situation. That is completely fine with me. But for L3, it's the core incentive is curiosity, and that if that is that, then we can keep it like 3 months, 4 months, have all the nice discussions, because things beyond research very rarely change. Things beneath research like LLMs, RAGs, n8n, Copilot, every other day you'll see 5 or 6 releases every single day. In research, maybe 5 months, 6 months, you'll see one release, five release, two release. That's it. So that's how the structure is going to be. Share details of timing and all very soon. Very soon, I'll share details and timing all on the group. If you're not on the group, please join the group. Mohit, I'll share the
Yeah, do you
link.
have
I
QR?
assume if somebody is here, I think. I mean, how else would
Mostly we would
Abhi?
be
So
on group.
she are you? Huh, most of you are on groups. If anybody is not on the group, please let me know. Can you share the n8n JSON notes of all the different types? Yes, obviously. I'll share them right now. Okay, downloads n8n. I'll share both of them. I'll share three of them. Oh, wait. Wait. I'll share them soon because I'll have to remove my credentials from it. There are my session credentials baked into them. I'll remove them and then I'll send it. Okay. Group link, please. Okay.
Okay. Yeah. You can,
Invite. I'll send it.
yeah. Do you have it? Okay, great.
Yes, I have it. Here is the group link.
Okay, please feel free to share with your colleagues, friends, and those who are interested in such session. Are we going to have a dedicated session for L1 course again? Because there are a lot of people have to drop for some reason.
Sure. We can. Or we can clip this session and put on YouTube. If not, okay, fine. We can take a live session as well.
Only, yeah, just
However,
detail
for
walkthrough.
sure, for sure.
Yeah.
Well, let's do one thing. We'll take the first session when
Open
we
to all.
release all. Open
Yeah.
to all.
Yeah.
Now let me just check if I have any credentials in the uh, n8n reference.
You created meeting for 3 hours, right?
Huh? Yes.
Meeting for
So this will end on 12:30.
that's good. We have ample of time. I love about this platform. It just sticked out if you going next.
Okay, okay, okay. I don't have any credentials in here. Even if you have my credentials, it won't matter because I'll be deleting them anyway.
There is one similar platform I have seen like Tailscale called Ngrok.
Ngrok, Ngrok, like rather, NGROK is it's not a platform, it's basically a library which was used for tunnel punching. And
Yeah,
basically, Tailscale uses NGROK under the hood, but it just wraps it into a good UI and everything and quality of life features. That's all. NGROK does the same thing. If you punch a hole through NGROK in your firewall, you'll have to handle this SSL certificates. You'll have to handle reverse proxies. You'll have to handle how the what do you call security headers are treated. How what the API has to do. Which port does it map to? Everything you'll have to do. With Tailscale, all you do is Tailscale funnel port number. That's it. Everything is taken care of.
configurable.
On, on
More
Tailscale, yes.
configurable. Yeah,
Yes, easy. Like
yeah.
much easier than and plus the point is it's security risk if you are doing it and you don't know what you're doing and you're using NGROK. It's a security risk, so it's much better. And even seasoned professionals sometimes miss a few things, so it's much better to use Tailscale. uh Hunter all nodes preferences, this is was the one, right? Ah, Dheeraj, it's being sent, it will be sent shortly. Okay.
Those who stayed back pretty late, just a tip to save your tokens. There is a GitHub repo called RTK, and this is specifically when you run into the CLI mode, Cloud Code or GitHub Copilot or anything. If you run this in CLI mode, download GitHub RTK, RTK repo. It will help you to save your tokens. कल के रिकॉर्डिंग से निकाल देना.
Yes. Okay. Yes, we are good to leave. Chalo. Let's now I'll see you guys in L1 then. Okay.
Yes, yes.
Chalo.
Super excited.
Let's see. All right. Chalo.
Okay. See
Thank
ya
you very
on.
much, Parikshit.
Thank you.
Thanks.
Who was talking? I'm really sorry. I cannot
Yeah,
make out
Sandeep here.
who. Okay.
Yes.
Okay. Okay.
Oh, it's okay, okay. It's yeah, we will take. It's more of a networking per se. Codes, basically DNS. It's all to the topic of DNS and networking. So he's
For
asking
sure.
the discussion we had for Tailscale and Ngrow.
Tail scale.
So
That's a completely different field. If we can, if we find time, I will take a session on self-hosting.
yeah,
Self-hosting, like everything, TrueNAS and your Proxmox, tunneling, networking, basics of
Xbox
networking and
would be
everything.
really good.
Proxmox is a really nice entry into Kubernetes and everything.
By the way, Docker would have some part of networking. I just wanted to brag some uh, or market about my Docker upcoming Docker class. So yeah, in case. But of course, you can join the free session. self-hosting would certainly help us. Yes,
For sure.
that is
Even that we can do that as well. I could take a small session in one of the Docker batches
yeah.
for Tailscale and everything. Rather, Tailscale has native integration for Docker desktop, so you can log in and
Yes.
do everything. Sidecar, all of that. Okay,
Good.
ठीक है.
Okay.
चलो.
Yes. We're saving 25 minutes of time for tagline. Okay, great. Thanks. Thanks, team. Bye all.
Bye. I mean, I'll have to stay this.
Yeah. I have just released the Docker sneak peek video, Docker in 8 minutes on VoidInfinity. This was based on the session class that I have attended from Michael Kirisk. Yes, if you okay, it's those who are still here. Let me grab that link. So it's basically sneak peek of what we are going to cover in Docker. So when we are planning to have this L1
Next week.
next week.
Next week, mostly admissions will start, and very next week will start because since it's a 1 week batch.
Yes.
I mean,
I think
based
logically
on
would be 1 week, 3 hours. That would be easily and digestible. 6 hours.
I mean,
Yeah.
it depends on people. Okay, however you want it, I can deliver it in any form. Like 6 hours, 2 days, 3 hours, 4 days. However,
Can Mohini do this batch?
yes, by all means, because it's going to be absolute basics.
No. Because if it's a weekend, it's difficult for me the parallel batches. But if it's weekdays, I can do some. Let's try.
Okay, let's see. I'll put a post on the group. Let's see what
Yeah.
people have to say. Okay,
And we are
should
also
I?
posting on LinkedIn, right? No issues from the
Yes,
company.
yes. Yeah, it will be
We
heavily
will,
marketed.
yeah,
No
we will
problem.
ask, in fact, our all batch members to go ahead and repost on LinkedIn. Because
Correct.
for me, I can't do that. I can do it for you. I can't do it
Correct.
for me. Yeah.
No worries.
Sure.
Okay. Chalo, I should head them.
Yes. Bye. Bye all.